This is our project on food chemistry and how chemistry is a driving force in the production of all different types of food. Food science deals with the production, processing, distribution, preparation, evaluation, and utilization of different types of food. Basic food chemistry deals with three primary components of food: carbohydrates, lipids, and proteins. There are many different types of concepts that make up food chemistry. This includes theories of transport phenomena, physical and chemical thermodynamics, chemical bonds and interaction forces, quantum mechanics and reaction kinetics, bipolar science, colloidal interactions, nucleation, glass transitions, and freezing disordered or non-crystalline solids. All different types of people use food chemistry in their daily work, including chefs, bakers, farmers, and food production companies. A lot of different scientists over the years have been involved in the food chemistry fields and researching and developing new types of information based on the field. Carl Wilhelm Schlee, who isolated malic acid from apples in 1785, was among the first. In 1874, the Society of Public Analysts was formed with the aim of applying analytic methods to the benefit of the public. By the 1950s, a large percent of the population was concerned with the quality of food, so many chemists came out to test different additives in foods. Harvey W. Wiley did research at the U.S. Department of Agriculture and aided in the creation of the United States Food and Drug Administration, or the FDA, which still regulates food to this day. The American Chemical Society established their Agricultural and Food Chemistry Division in 1908, and the Institute of Food Technologists established their Food Chemistry Division in 1995. Many books and volume sets have been written on food chemistry, including this one by Paul Finglas, the editor-in-chief of Food Chemistry, a series of publications that deal with the advancements of the chemistry and biochemistry of foods. Okay, food chemistry can be applied to many different types of foods and food groups. The first of which we have is vinegar. Its base materials are fermented to make an alcohol, then fermented once more to make an acid. Differences in the production of vinegar cause different types of vinegar to be formed. The next one we have is bread. Chemical reaction between baking soda, baking powder, and/or yeast within different mixtures of flour cause differences in the physical attributes as well as taste in varying forms of bread. In candy, food chemistry plays an important role. When heated with water, excess sugar causes the formation of supersaturated solution, and when cooled, a crystalline solid can form. This forms candy such as fudge, nougat, and fondant. Addition of extra fructose or glucose can alter the chemical makeup to form a non-crystalline candy structure such as lollipops, candy canes, or caramel. Caramel. Intermolecular forces between sucrose are broken when heated at a slow rate. A highly viscous solution is formed when the heating is done at a slow and steady rate in order to avoid sublimation. That's how caramel is formed. The next thing we have is fudge, which we're going to be showing you in our video today. We make fudge and we pay close attention to how sugar begins to dissolve in a solution of warm milk. It enters a cooling phase, and in this phase, if the mixture is stirred, large crystals will form too early and give the fudge a grainy texture. And that deals with formation of sugar crystals over time. So instead, we let it sit for a while and then add it to a pan, and then the sugar crystals are nice and fine, and you don't get a grainy texture in your fudge. So this is how we make fudge.